Hello, welcome to my channel. Today I will discuss how to analyze your data by using One Way ANOVA in GraphPad Prism 11. Let's start. First, you have to click grouped here, and then enter or import data into a new table. Select here and then select the replication. If you have 3, just click here. If you have 4, make it 4. I have 3, so it's okay for me, and I need mean, error value, and normal data. Click create, and then this is the spreadsheet, and here you can write your treatment name. As this is one way, so we'll only consider the treatments, not others. This is one way variable. So first control and then salinity. In my case, salinity arginine. Sorry, this one should be salinity, and next one is salinity and arginine. Perfect. These 3 are treatments. Now I can input the data by manually. I am showing you these are the treatments and these are the replication, 3 application. So just Ctrl C, and then here you can click Ctrl V, and for salinity data same way, salinity data, and then you can arrange your data by this way as I am showing here. Perfect. So these are the data, and on the left side in control panel you can click graphs to check your graph. So I need summary data. Click here and this summary data, so I can choose this graph. Okay, so here these are the data: plant height centimeter, and you can write here the graph name. I don't need it, as this legend are control salinity and arginine. It's already written here, so you can delete this. Right, so these 3 are different bars indicating control salinity. So I want to change the color. First one I can keep green, and then in case of second one, salinity, we can choose red, apply, and then in case of salinity arginine we can choose blue. Perfect. So this 3 color, and if you don't need borderline, so you can reduce borderline, none. For salinity also borderline, none. For salinity arginine, borderline, none. Okay, perfect. So this is the graph. You can click here. So now I will show how to analyze this. You can analyze by using here, click here, or in result part just click new analysis, or here in top bar analyze. So I am showing how to analyze by clicking here. So as I told, this one is one way ANOVA, so you can click column analysis and one way ANOVA, and these 3 are your treatments: control, salinity and arginine. Just click OK, and in first experimental design it will show how they interact with each other. Group A, B and C, these are normally distributed, as I checked it, and I will show also how they are normally distributed or not. And then repeated measure, it can't show anything because we didn't select any repeated measures. And multiple comparison, pairwise comparison, you can do 3 way. One is compare the mean of each column with the mean of every other column. That means you can compare the mean of every columns with the mean of other columns, this one. And also you can check the mean of one column with the mean of control column. That means to compare with the control. If you click here, you can click with the control with the salinity. That means control and salinity will come here. So I don't need this. And also another way, compare the means of pre-selected pairs of column. That means you can compare your data with two comparison. For example, in here I can compare my data with control data with salinity data, and also I can check the control with the salinity and arginine data, and so on. You can make so many comparison by using this. As I don't need this, I need only this one. That means, sorry, this one. Compare the mean of each column with the mean of every other column. It will cover everything. Now we can check the post hoc test, that is the correct the multiple comparison with the statistical hypothesis testing. They recommend Tukey. You can choose also Bonferroni, CDAC or home CDAC, and this one is not, Newman calls is not recommended in this case, so you can choose just Tukey. And also multiple comparison option, report multiple adjust p-value, this is defaulted. You can keep here graphing, graph confidence interval, you can check here. Additional result, descriptive statistic, this is very interesting, I'll show you. Also report comparison of model using AICS, you can check also this effect size, also we can check this. And right, so we can click here, and this one is residue. You can check the QQ plot, that is the quantile plot, to check the is they are normally distributed or not. And you can also do heat map by this way, heat map plot. Okay, let's check. So here we have seen three different window scheme. First one is our ANOVA data. Here p-value, if statistics is 47, here numerator is 2 and denominator 6, that is 26. I will show it in later. P-value also 0.002, which is less than 0.05, that means highly significant level, yes. And if you want to know details about the ANOVA table, please click one of my biostatistics video. I will give it here in the comment box, you can check there. So this one is ANOVA table, treatment and residue values, that is our treatment are highly significant, the p-value is 0.002. and so we can check multiple comparison. Here they give the control versus salinity, arginine, salinity versus salinity, arginine, and in every case these are significant, that means below threshold, that are highly significant, and also they showed the lettering, A for control and B for salinity. Here A for control, C for salinity arginine, salinity B, and C for salinity arginine. You will see also the compact letter display, that means CLD, here A, B, C for control, salinity and arginine. And also, as I told that I can show the QQ plot. In QQ plot, right here the value, to check the QQ plot we can click here the graph, right, this is the QQ plot. Here QQ plot, it almost showed that our data are normally distributed, that is very close to the straight line, that means that are normally distributed. And you can also check the heat map, this is the heat map, how actually they are interrelated with each other. Okay, now we can go our analysis, data 1 analysis, sorry, this is the result, right, these are descriptive result, this is a descriptive result, right, and multiple comparison, ANOVA, right. By this way you can analyze your data in ANOVA. Now I'll show how to put this later in your graph. Just click the here, which is data 1. These are the graph for your data, control, salinity and salinity arginine, one way ANOVA. Now how can you add? Just click here on the top bar, you will see here CLD, compact letter display. Just click here, it will give automatically, it will give the lettering, and then you can export your data in TIF or JPG or PNG, whatever you want, and then you can just export it. Okay, you can replace, or you can send it to the PowerPoint, it will go to PowerPoint. Thank you. That's all about today's video. Thank you so much for watching this video.